In center of a triangle is a second of the four centers of a triangle and is defined as a point of intersection of angle bisectors of the triangle. Let's get started with this triangle where we have three vertices with given coordinates. Let's call this as vertex A with coordinates 4, -2, 4, -2, and B with coordinates -2, 4, -2, 4, and C is third vertex with coordinates 5, 5. In order to find in center of this triangle, we will first need to find lengths of the sides of triangle. If we follow the naming conventions which we use for triangles, the side opposite to vertex A should be named with small a. So this length here is A, and this length opposite to the vertex C should be labeled as C. Let's label this as C, and the side opposite to that of vertex B should be labeled as small b. Now we are going to find out values for these A, B, C. Let's find these values. A is equal to the length of side BC, and by using the formula x2 minus x1 whole square plus y2 minus y1 whole square root, we can find the length of the side of this triangle. So here A would be equal to, this will give A equal to 5 plus 2, because 5 minus -2 will ultimately become 5 plus 2 whole square plus 5 minus 4 square, and then square root. This is going to give us 49 plus 1, which is equal to 50 square root. And if we want to simplify 50, we can break it into 25 times 2, and 25 square root. Let's separate 25 times under root 2. This is equal to 5 times under root 2. So this is value for A here. And now we are going to find out value for B. B would be equal to, similarly B is equal to length of the side AC. So this is AC, and the formula is still going to be the same, x2 minus x1 whole square plus y2 minus y1 whole square, and then square root. And this time we are going to calculate B, and B will be equal to 5 minus 4 square plus 5 minus -2, and then square, and we will take the square root, and this length is equal to 1 plus 5 plus 2, that's 7 square, and this is again exactly the same length as A. So let's put down the value here. This will be equal to 5 into under root 2 again. And now we are going to find out value for C, and let's find out C. For C, we have C equal to length AB, and we will still be using the same distance formula, which is equal to x2 minus x1 square plus y2 minus y1 square, and then taking square root. So this will give us C equal to 4 minus minus 2, 4 minus minus 2 whole square plus minus 2 minus 4 whole square, minus 2 minus 4 whole square. So this should give the length of C, that is equal to 6 square plus 6 square. This is going to be 72 square root, 72 square root, and if we do the linear factorization, the linear factorization of 72 could be, we use tree diagram, this would be 2 times 36, and this would be 6 times 6, this is 2 times 3, and this 6 is again 2 times 3. So all the linear factors of 72 are equal to 2 times 2 times 2 times 3 times 3. So here if we make pairs, then this pair and this pair, so this will be 2 times 2 times 2 times 3 times 3, and here we can get this pair and this pair. This means we have one element out of the pair, 2, and then another element out of a pair, this is 3, and then 2. So this is equal to 6 times under root 2. So these are the values of A, B, C, and now the in center of the triangle ABC is equal to AX1 plus BX2 plus CX3 over A plus B plus C, and similarly AY1 plus BY2 plus CY3 over ABC, A plus B plus C. So this way, if we substitute the values of A, B, C, and then x1, y1, x2, y2, and x3, y3, we will have values here. What is A? That is, A is equal to 5 times under root 2. So this is 5 times under root 2. And what is value for x1? That is the x component of A, which is 4. So this is 4 plus B is again, what is value for B? the value for b is same as 5 into under root 2, and x2 would be minus 2. This is 5 into under root 2, 5 into under root 2 minus 2, and the third would be plus, see, that would be 6 times under root 2 into 5 divided by a plus b plus c, a plus b plus c. And similarly, now we are going to calculate value for y, which is 5 into under root 2, 5 into under root 2 times minus 2 plus 5 into under root 2 times, this was 4 plus 6 into under root 2, 6 into under root 2 times 5. Over a plus b plus c. This will be a plus b plus c. So this is what are the coordinates of the in-center, and now we can simplify them by taking under root 2 as common, and if we take under root 2 as common, what is left behind is 20. 5 times 4, 20 plus, this will be minus 10, and then plus 30. Plus 30 over value of a plus b plus c is 5 into under root 2 plus 5 into under root 2 plus 6 into under root 2 and comma, and again we take under root 2 common, under root 2 common, and here we have minus 10 plus 20 and plus 30, and in the denominator we have 5 into under root 2 plus 5 into under root 2 plus 6 into under root 2. So here we draw these brackets, and now what happens is we add up these, and 20 plus 30 would be 50 minus 10, that would be under root 2 times 40 over 16 times under root 2. So this is 16 times under root 2, and here we have under root 2 times same 40 over 16 times under root 2, 16 times under root 2, and let's put the brackets and then simplify. Under root 2 will be cancelled with under root 2, and these could be simplified by dividing 4 with the numerator and the denominator, 40 over 16. So this is equal to 10 over 4. So if we divide it both by 8, that would be 5 by 2 and then 5 by 2 over here. This is what is the in-center of the triangle ABC. So if this angle bisector from here meets side BC at this point, let's call this as D, and this angle bisector from B meets here, and the angle bisector from C meets at this point. So D, E, and F. Then this is the point which is called the in-center, and its coordinates are 5/2, 5/2. And it is at equal distance from all the three sides of the triangle. And now the next part of the question is that we are going to find the coordinates of the point where angle bisectors of an angle of a triangle meet to the opposite side of a triangle. Now we have, let's say we call this point as F, which is a point where the angle bisector coming from C meets the side AB at point F, and we will find out coordinates for F. F divides the join of AB. So for second part, F divides the join of AB in ratio which is equal to the length of the corresponding sides, equal to AF over FB. But this is equal to the ratio AC, the corresponding length of the side, AC over BC, which is 5 into under root 2 over 5 into under root 2, means that this is 1:1 ratio, because it seems like D is in the middle. So if we have this triangle for which A has coordinates 4, -2, 4, -2, and at the other end there is the point B with coordinates -2, 4, -2, 4, and here is the point F, which divides the join of A and B in ratio 1:1. Then this is equal to K1 and this is equal to K2. Let's call this as X1, Y1, and this as X2, Y2. And now we can find coordinates of F. For coordinates of F, XY, X is equal to K2 X1 plus K1 X2 over K1 plus K2, and Y is similarly equal to K2 Y1 plus K1 Y2 over K1 plus K2. So let's substitute the values, and here because K1 and K2 are 1:1, therefore the task is much easier than we initially thought. So this would be simply addition of x components, 4 minus 2, 4 minus 2 divided by 2, that would be x, and y would be simply addition of y components divided by 2. That would be minus 2 plus 4 over 2. So this way we can have this as 1 and y is also equal to 1. So the coordinates of f are, so f is with coordinates 1, 1. And similarly, if you need to find out coordinates of the points on the other sides of the triangle, you can find this similarly.